In this video, I want to talk about equivalence relations. In order to do that, let's start by defining a relation on a set A. A relation on a set A is any statement that is either true or false for each ordered pair xy of elements of A. Examples of relations on appropriate sets. We could say x equal to y is a relation. If you give me an ordered pair, this is either true or false. We could say x is less than y. If our set is a set of lines, we could say x is parallel to y. If you give me any two lines, this is either going to be true or false. If our set is some kind of animals or people, we could say x is the offspring of y. And we could continue this idea. An equivalence relation is going to be a special kind of relation. For an equivalence relation, we usually denote it by this tilde symbol. So we would say x is equivalent to y. And so this is how we talk about elements being equivalent in our equivalence relation. So an equivalence relation is a relation with three properties. The first property is the reflexive. For every element x in our set A, we need x to be equivalent to x. The second is symmetric. If x is equivalent to y, then y must be equivalent to x. We need to be able to change order. And then finally, transitive. If x is equivalent to y and y is equivalent to z, then x is equivalent to z. Some examples. One would be equality. Any number is definitely equal to itself. If the number x is equal to y, then we can say y is equal to x. And if we know that x is equal to y and y is equal to z, then we can conclude that x is equal to z. Another example, if we want to deal with weight, x weighs the same as y. Every object weighs the same as itself. If object x weighs the same as y, then we can say object y weighs the same as x. And if we know x weighs the same as y and y weighs the same as z, we can conclude that x weighs the same as z. We could do x is the same color as y. Every object is the same color as itself. If x is the same color as y, then y is the same color as x. And if we know x and y are the same color and y and z are the same color, we can conclude that x and z are the same color. If we want to talk about words, we can say x is synonymous with y. So every word is definitely synonymous with itself. If x is synonymous with y, then y is synonymous with x. And if we know x and y are synonyms and y and z are synonyms, then we can conclude x and z are synonyms. Let's do an example showing different things are actually equivalence relations. In the set of rationals, we're going to say r is equivalent to s if and only if r minus s is an integer. So let's show this is an equivalence relation. First, we need to show this relation is reflexive. So we need to look at r minus r. Well, we know that's 0, which is definitely an integer. So that means r is equivalent to r. So we definitely have the reflexive property. Next, we need symmetry. To do symmetry, we suppose r is equivalent to s. So that means r minus s is an integer. Well, we want to be able to switch order here. So s minus r is going to be negative r minus s. Switching the order is going to change the sign, but that's still an integer. Changing the sign of an integer is still an integer. Therefore, we have s is equivalent to r. So this is symmetric. Next, we need to show the transitive property. Let's suppose r is equivalent to s and s is equivalent to t. We need to show that r is equivalent to t. We know r minus s is an integer. And we know s minus t is an integer by the definition of this relation. If I look at r minus t, I'm going to rewrite this as r minus s plus s minus t, so I just added in 0. Regrouping, I have r minus s plus s minus t. I know r minus s is an integer, and I know s minus t is an integer, and I also know if I add two integers, I still get an integer. So therefore, I have r is equivalent to t. So yes, this is an equivalence relation. Let's do one more. In R star, we want to say A is equivalent to B if and only if A over B is a rational number. And we want to show, is this an equivalence relation? Let's start with the reflexive property. Well, we know A over A is going to be equal to 1, which is a rational number. So we can say that A is equivalent to A. Next, let's consider symmetry. Let's let A be equivalent to B. Then we know A over B is a rational number. Well, flipping the fraction over is still going to be a rational number. It's just going to be the reciprocal. So that tells me that B is also equivalent to A. Finally, let's do transitive. Let's let A be equivalent to B and B be equivalent to C. So I know A over B is rational, and I know B over C is rational. And I want to look at A over C. Well, I'm going to rewrite this as A over B times B over C. This is a rational times a rational, which we know is still a rational number. So therefore, we know A is equivalent to C. So yes, this is an equivalence relation.